Chapter 7, we are focused on scatter plots, association, and correlation. This chapter is focused on using data that has two columns, an X and a Y column, creating graphs, and then looking if there are relationships between those two variables. So we have quite a bit of vocabulary to start with, so let's get started with some vocab. First vocab word, obviously, what is a scatter plot, which hopefully you're familiar with. These are graphs that show relationships between two quantitative, that's an important piece. You have to have quantitative data, and they are measured on the same cases. Now, if you are unfamiliar with what a scatter plot looks like, it's literally an array of points. Now, there's two different variables with a scatter plot. We usually think of them as the x-axis and the y-axis. Maybe you've heard the word dependent and independent, perhaps, but we have some different words that we use in statistics, and the first one is the explanatory or predictor variable. This is the variable that accounts for, explains, predicts, or is responsible for the response variable. This is the one that is always plotted on the x-axis. So this would be, from maybe the old words that you're used to, this would be your independent variable. This is the one that doesn't get affected by other things. Then we have the response variable. This is the variable of interest, or that you are hoping to later predict, and this is the one that we plot on the y-axis. And this is also known as the dependent variable. Okay, so when we make a scatter plot, which is what we're going to be doing today, we have one big important task today, and that is describing the scatter plot. So when you describe a scatter plot, you describe three things about it, and all three are required. So the first one that we describe is, what direction is the scatter plot going? You have one of two answers. Are the points going in a positive direction, which means they're going upward, or are they going in a negative direction or downward? So you're either going to say positive or negative for the direction. Then you have to discuss the form. Do the points that you've graphed cluster into a fairly linear straight line pattern? Are they perhaps curved, where we would call it nonlinear? Or is there no pattern? So for the form, you have three words: linear, nonlinear, or no pattern. And then there is the strength of the graph. Are the points in a very tight and not spread out pattern? That would be considered strong. Are they in a pattern, but maybe it's not as tight, it's a little more spread out? That would be considered moderate. Or are they spread out all over the place where there's really not a pattern at all, and that would be considered weak? So there's three options for strength: strong, moderate, and weak. So what we're going to do to help you, maybe give you a little better understanding as to how to use these words, we're going to look at 4 graphs, and we're simply going to label for each graph the direction, the form, and the strength. So here's our first example. Describe the direction, the form, and the strength. So let's look at this first example. So we talk about direction. Well, it looks like it's going up, but then it kind of looks like it goes down. Well, hopefully you've seen graphs that look like this before, these U-shaped graphs. So when you think about direction, which direction is the U going? Is it opening up, or is it opening down? This one is opening down, so this would be negative. The form, this is obviously curved. Since it is curved, we would use the word nonlinear. And in terms of how, is it strong, is it moderate, is it weak? These points, if you notice, there aren't really any stragglers. They all cluster around that U that I just drew. So because they're pretty tight to that U, we would call that strong. So again, in summary, this is a negative U. It is nonlinear because it's U-shaped, but it is strong. Let's go across. So again, this one, if we think about the direction that it's going, it looks like it's just going up and it's going to continue going up. So that would be positive. Now, I just drew a straight line. I didn't need to bend my line to go through these points. So that would be considered linear. Now, if you notice, you see how the points are a little wider. Some of these, like this one here, there's got some distance there. There's some distance there. There's some distance there. They're not quite as tight-fitting. This I would consider moderate. So again, in summary, we're looking at positive, linear, and moderate. Let's look at the next one. So if I try and kind of follow along with my dots, if you notice, I'm obviously going in a downward pattern. So that means that we are looking at a negative form, a negative direction. The form, those look like they are very much in a straight line. And they are very, very tight together. There is not a lot of gap from the line to the dots. So we would consider this one, again, strong. So it's negative for the direction, linear for the form, strong for the strength. This last one. So if I kind of had to draw a line, my thought would kind of be more this direction. So it looks kind of negative. Now in terms of form, I don't know if there really is a form. I mean, you could say that it's linear, but that's really spread out. And because it's really spread out, we would call that weak. So in terms of summary, definitely negative. Linear, maybe you would even say no pattern. I could consider, instead of linear, I could definitely say no pattern here. And it is definitely weak because those dots are spread all over. So that's some of the stuff you're going to be doing on tonight's homework. Let's look at some other examples. Suppose you were to collect data for each pair of variables. You want to make a scatter plot. Which variable would you use as the explanatory? Remember, that's the one on the x-axis for explanatory. And which one as the response variable, which is the y variable? What would you expect to see in the scatter plot? So when we talk about explanatory and response, explanatory is the one that's doing the decision making. The other one is the one that is being affected by the decision. So you're selling t-shirts at a store. You have to set a price and you got to sell t-shirts. Which one is the one that's going to make the decisions? Well, to me, that would be the price. The price is the one that's going to go on your x-axis. The number sold, because price predicts how many you sell, that goes on the y-axis. Now, then we have to think about if we were to make a graph, what would happen? Well, as price gets higher, so price is this way, as we go higher this way, the number sold is not going to go up, it's going to go down. So that means that it is negative. The form, I would definitely say it's linear because as the price goes up, number sold is definitely going to go down. And then the strength, yeah, you're going to maybe have a few people who might buy the shirt regardless. But I would say the strength is going to be pretty strong. They're going to be pretty tight to that straight line. So we said the explanatory variable was price. The response variable was the number sold. It is negative, it is linear, and I'm sorry, that should say strong. So let's just scribble that out and say strong. That was a typo. All right, so the next one, scuba diving. Scuba diving, obviously, you know, is underwater. So the depth that you go, the deeper in the water you go, what's happening with the water pressure? So which one is making the decisions? That would be your depth. For those of you who maybe have never gone, or think about in a swimming pool, if you've ever gone into the deep end of a swimming pool, do you feel your ears start to feel pressure when you go in the deep end and you go way underwater? The depth makes the decisions. And the water pressure, which is going to be your y variable, is based on how deep you go. So let's think about this one. Depth is x. So as the depth goes up, as you go deeper, the water pressure on your ears is going to get stronger. It's going to go up. So this would be one that is positive. That is definitely, if you don't know anything about scuba diving, that is a scientific rule. It is definitely a linear property. It's not going to start curving a different direction. So it's definitely linear. And this is another one that directly affects each other. There's definitely a strong relationship there. So the explanatory was depth. The response is your water pressure. It is positive, it is linear, and it is strong. Now let's think about scuba diving again. We're still thinking about depth, how deep you go, but this time we're thinking about visibility. How far in front of you can you see? Well, which one's going to make the decisions? If you don't know, that again is going to be depth. Because think about an ocean. If you go deep in the ocean, it gets darker. It gets harder to see. Now, visibility. That's definitely your why. So let's think. Depth. As we go higher this direction, what do you think is going to happen with visibility? Well, if you think about an ocean, the deeper you go, the darker it definitely gets. So visibility is going to go down. Now, it is linear. You're not going to suddenly, when you go deep in the ocean, you're not going to suddenly find light. So it is linear. But I am not going to say this is strong, and here's why. There's other outside factors. It could have been a rainy day, so the water just got stirred up from the rain. If it's sunny outside, you're going to be able to see better than if it's cloudy outside. So there's other factors that affect visibility other than just your depth. So I personally would say that's probably a moderate case instead of a strong case. So your explanatory variable is depth. Your response variable is visibility. It is down, so it's negative, linear, but it's moderate. All right, so the last one. You're looking at all elementary school students, and the two things you're comparing are their weights and their score on a reading test. Well, hopefully you're sitting here thinking, what the heck? That makes no sense. And that's exactly right. This one has absolutely no relationship. You can put whichever variable you want wherever you want. So in terms of answers, I just randomly decided the explanatory variable is weight. It doesn't really matter because they're not related. The response variable is going to be score. But again, because they're not related, it doesn't really matter which one you label with which. So you're going to do some of those for your homework as well. So let's keep talking about this association stuff. So, are grades that students earn higher now than they used to be? Do people tend to reach puberty at a younger age than in previous generations? Does applying magnets to parts of the body relieve pain? And if so, are stronger magnets more effective? Do students learn better with more use of the computer technology? These are all questions that pose something called an association. An association is simply a relationship between two quantitative, must be quantitative, variables. And it can easily be shown using a scatter plot. So an association is simply, are they somehow related? So let's look at a couple of questions. A study examined brain size and IQ for college students. The scatter plot shows the performance IQ scores versus the brain size. Comment on the association seen in the scatter plot. Well, look at that scatter plot. What do you notice about the dots? Are they tight together? Are they spread out? Hopefully you're looking at this thinking those dots look to be kind of all over the place. And anytime we see dots all over the place, we start thinking there really isn't a relationship. And that's exactly what you would say here. Since the data points are scattered kind of all over, there is not an association between brain size and IQ. So let's look at another one. The fastest horse in Kentucky Derby history was Secretariat in 1973. The scatter plot shows the speeds in miles per hour of the winning horses each year. What do you see? In most sporting events, performances have improved and continue to improve. So surely we anticipate a positive direction. But look at the form. Has the performance increased at the same rate throughout the last 130 years? So first of all, this guy right here, that's Secretariat. That was the fastest horse in Kentucky Derby history. Has been, may not ever be anybody faster. So let's look at what we see going on here. In years, as the years have gone up this way, look at the speeds. The speeds have actually increased as well. I'm sorry, that was not Secretariat. Secretariat was the fastest horse. The fastest horse is this guy up here, 1973. So as you can see, it went up. But does it look like it's following a straight line? Can I keep going straight? And the answer is no. I have to start curving. Why is that? Well, think about it. Can you infinitely keep getting faster? And the answer to that is no. There is limitations on the human body. There's limitations on horses' bodies. So this is definitely not a linear relationship. But is there an association? Possibly. The data has definitely increased steadily, but it's reached what we call a plateau. It's where things kind of start to level off. And so we would have to call this nonlinear, but there is definitely a relationship between the two. So the last thing we're going to talk about today is how do I actually make one of these scatter plots? Because we've looked at them now, we've answered several questions about them, but how do we actually make them? So the most challenging part about creating a scatter plot is creating that scale for the x and the y axis. Once you have the scale, the rest is just graphing some dots. So I do have kind of a helpful suggestion for creating that scale. So to find a scale, this gives you kind of a rough outline. Find the range, and if you don't remember, the range is the highest data value minus the lowest data value. Then divide that number by one less than the number of boxes that are on your grid. Okay, the reason we do one less is because then you have a little more room to work with in terms of rounding. When you get that answer, you'll want to, trust me, you don't want to count by like 1.3. It is okay to round. It's okay to round up to a 2. It's okay if it's 1.7, round to 2. If it's, and notice it says always round up. That's a helpful hint as well. If it's 3.7, it's okay to round up to 5. You can skip a number. It doesn't have to necessarily be the very next number, especially when you get into bigger numbers, 2-digit numbers. If it's, 27.3, round it to 30. That's okay because it's easier to count by, amounts that are nice and in multiples of 10. And most importantly, you are not required to start at 0. If all of your data value is 100 and above, you can start at 100. But make sure you use a break. And if you don't remember what that is, it looks like this. It's just that little lightning bolt zigzag thing. If you're doing it on the x-axis, that's the direction you go. If you're using it on the y-axis, that's the direction that you go. It just tells the reader that you're not starting at 0. Once you've figured out what to count by and you've made your scale, make sure you include labels. And remember, labels also include units. So don't just write height and then inches next to it so that people know it's in inches. And then graph your data. So we're going to apply these skills and we're going to do 2 different scatter plots together. So the table below shows the heights and weights of 5 starters on a high school basketball team. Create a scatter plot of the data, then of course describe the association using direction, form, and strength. So for each one of these, remember we have height and weight. Height we're going to put on the x-axis, weight's going to be the y-axis. So we're going to say height, and that is in inches. And we're going to say weight over here, and that is in pounds. So we need to find the range. So if you look at your X data, 67 is my low, 77 is my high. So 77 minus 67 is 10. And then I got to divide that by 1 less than my number of boxes. So if I count my boxes, I'm counting 1, 2, 3, 4, 5, 6, 7, 8, 9. I count 10 boxes. So we're going to divide by 1 less, so we're going to divide by 9. So that gives me approximately 1.9. So what should I count by? I'm going to count by 2's because it's very easy to count by 2's. And the first number, might as well start with the lowest. So I might as well start with 67, which means I need a break on the x-axis. And if I count by 2's, then would be 69, then 71, then 73. That's not a 3, that looks like a 5. Then 75, then 77, and how high do I gotta go? 77, that's all I gotta go to. So I'm done with the x-axis. Let's look at our y's. My low is 155, my high is 240. So 240, take away 155 is, it looks like, what, 85? Divided by, how many boxes do I have going up? I count 1, 2, 3, 4, 5, 6, 7, 8, 9. I count 10 again. So I'm going to divide that by 9. And I get approximately 9.4. So I'm just going to round that up to 10 because that's a nice number to count by. And so I'm going to start counting at, what's my lowest? 155. Sounds good. Count by 10. So then 165, 175, 185, 195, 200. Oops, not 200. 215. Sorry, 205. I can't count today. So 205, 215, 225, 235, and finally 245. All right. So we've made our axes. We've done our labels. All we got to do is graph some points. So at 67, I need to go to 155. I'm going to change colors. So there's 155. At 72, which is in between 71 and 73, I need to go up to 220, which is in between 215 and 225. 77, I need to go up to 240, which is between 235 and 245. 74, which is between 73 and 75, I need to go up to 195. And 69, I need to go up to 175. And so there's my scatter plot. So now let's talk about the 3 things it asks for. So the direction, hopefully you are automatically thinking this is positive. The form, I would definitely say that is linear. And the strength, I would say those are strong. 3 of them are even in a straight line. The first one, the second one, and the last one almost look like a perfect straight line. So I would definitely call that strong. Let's do our last one. This one's a little harder. Definitely more data values. Threw in decimals. So the table shows the temperature outside and the sales for ice cream. Create a scatter plot and again describe the direction, strength, and form. So temperature obviously makes sense for X and sales is Y. So we're going to put temperature down here. And I'm just going to put a little degrees Celsius next to it. And ice cream sales. Throw a little $sign next to that. All right, so what do we got temperature-wise? What is the lowest? Looks like we have a low of 11.9 and I think a high of 25.1. So if we take 25.1 minus 11.9, I get 13.2 divided by, and this is the same grid, so it's 10 boxes again, so we're going to divide by 9. My calculator spits out 1.4, so we're going to round that up to 2 again. That should be a 2. There we go. So let's count by 2's. Now, obviously we don't want to start at 11.9. That's silly. I'm going to go ahead and just start at 11 instead. Because you can't start higher, you got to start lower. And because I'm starting at 11, I have to put in a break. Oh, you know what we forgot on the last graph? We forgot a break on the y-axis. Go back and add that. So 11, then 13, 15, 17, 19, 21, 23, 25. How high do I got to go? I have to go to 27 because I have a 25.1. All right, ice cream sales. Well, our low day is 185 and our high day is at 614. So 614 minus 185 is 429. I'm going to divide that by 9 boxes and I get about 47.6. So I am going to definitely make this one a 50. 50s are easy to count by. And I'm going to make a break here because you got to have a break. Okay, so what should we start counting at? Well, you could start at 185 if you wanted to. If it would be easier to start at 150, you could go down to 150. Maybe let's meet in the middle. Let's say 175. Because that's easy to count by 50s. So then we would have 225, and then 275, and then 325, and then 375, and then 425, and 475, and 525, and 575, and 625. And that works out perfect. All right. These are going to be a little harder to graph just because you're going to have to approximate a lot closer. So why don't we, for the sake of time, why don't you pause the video and plot your dots and then start it back up and my graph will be done. So hopefully you ended up with a graph that looks pretty similar to mine. Again, the dots do not have to be perfect. I am totally fine with you approximating. So let's talk about the 3 important things. The direction, this is definitely, and I'm going to run out of room here. We're going to squeeze it down here. This is definitely positive. It is definitely linear. And I would call this one strong as well. And that is the end of the first part of Chapter 7.